So this is Pencast for the order of operations number 2, the second video. What we're going to do is just work through 3 examples. In the first video we really went into detail on what the order of operations are. So we're going to now use them to simplify a few expressions. In example A, we have 4 to the power of 2 minus, and then in parentheses, 5 minus 2 to the power of 2 times 3. And we know from the previous video that we have to do what's in grouping symbols first. So that means that I'm going to have to do that 5 minus 2 first. So that gives me 4 squared minus, and I'm going to keep my parenthesis for now, 5 minus 2 is 3 to the power of 2 times 3. Alright, so I've done the operations that are within grouping symbols, and now I'm going to move on to the second step, which is simplifying any powers, roots, or absolute values. And we have 2 of them here. We have 4 to the power of 2 and then 3 to the power of 2. So I'm going to evaluate both of those. 4 to the power of 2 is 16, minus 3 to the power of 2 is 9, and then we have times 3. So the only 2 operations I have left in this expression are a subtraction and a multiplication. And we know multiplication and division come before addition and subtraction. So I am going to have to do the 9 times 3 next. So 16 minus 9 times 3 is 27. And now we only have one last step, and we've got 16 minus 27. And if we do that calculation, we find out that that's negative 11. And we're fully simplified. Example B looks more complex, and if your fraction arithmetic isn't good, then it can be more complex. Remember that each individual step, if you're really struggling, you can use your calculator. Also, if you want to get more practice, you can always do it by hand and then check each step with your calculator to make sure that you were correct. So what I have here is in parentheses negative 3 over 5 to the power of 2 minus 3 over 5 times 5 over 9 plus 7 over 10. Don't let the overall problem overwhelm you. We're only working on one little piece of this problem at a time. So I notice the first thing is that I don't have any operations to perform within grouping symbols. So the first thing I'm going to do is the exponent. So I have negative 3 over 5 in parentheses to the power of 2, which means I'm just applying this exponent to the numerator and the denominator. So negative 3 in parentheses to the power of 2 means negative 3 times negative 3, which is 9. And then 5 to the power of 2 is 5 times 5, and that's 25. Minus 3 over 5 times 5 over 9 plus 7 over 10. When I look at these operations that are left, I have a subtraction, a multiplication, and an addition. Well, I know multiplication comes before subtraction or addition, so I'm going to need to do that first. So I'm not going to do this one or this one. I'm going to do the middle operation, which is multiplication. So I'm just focusing on this piece right here, the 3/5 times 5/9. And I know with multiplication, I can cross reduce. So 5 and 5 are on one diagonal, so 5 goes into 5 once, 5 goes into 5 once. And then on the other diagonal I have a 3 and a 9, and I know 3 goes into 3 once, and 3 goes into 9 3 times. And now I can just multiply straight across. So I'm going to write out my whole problem. That's 9 over 25 minus 1 times 1 is 1, and 1 times 3 is 3, plus 7 over 10. So now I have a subtraction and an addition. and I know addition and subtraction are done in the order that they appear from left to right. So I'm working from the left to the right and doing the first subtraction or addition that I encounter, which is going to be this one. So now I need a common denominator. If I'm going to add or subtract fractions, you have to have a common denominator, and the common denominator between 25 and 3 is 75. So 25 times 3 is 75. Remember, you have to use the same number in the denominator and the numerator, and then 3 times 25 is 75. So that's going to give me 9 times 3 is 27, over 25 times 3 is 75, minus 1 times 25 is 25, 3 times 25 is 75, plus 7 over 10. Now that I have a common denominator, I can actually subtract these fractions. I'm going to work back up at the top. So remember, when we're subtracting fractions, we subtract the numerators and we keep the common denominator. So 27 minus 25 is 2. And then we keep our common denominator of 75. And then we've got plus 7/10. So once again, to add fractions, we also need a common denominator. And here, between 75 and 10, the common denominator is 150. So 75 times 2 is 150. And 10 times 15 is 150. So now we do the multiplication. 2 times 2 is 4. 75 times 2 is 150. Plus, now here we've got 7 times 15. And I like to do this in pieces. So 7 times 10 is 70. 7 times 5 is 35. And then we just add those together. 70 plus 30 is 100. Plus 5 is 105. So I've got 105, and then 10 times 15 is 150. Now that we've got the common denominator, we add the numerators, keep the common denominator the same. So 4 plus 105 is 109 over 150. And that's our answer. Not too bad if you take it piece by piece. Number C, once again, looks fairly complicated, but this one's actually going to go pretty quickly. So when you have fractions like this, where we've got a fraction bar, and then we've got expressions that we need to simplify in the numerator and denominator, we always simplify the numerator and denominator first. So the first thing I'm going to do, in the numerator of our first fraction, it says 2 to the power of 3. And 2 to the power of 3 means 2 times 2 times 2, which is 8. And then in the denominator, I have another 2 to the power of 3, which is 8. And then I've got that plus 1. And that's all being raised to the power of 2. Divided by, now here, I've got 8 minus negative 2. So remember, with subtraction of integers, you change subtraction to addition of the opposite. So minus a negative becomes plus a positive. So 8 plus 2 is 10. Over 3 to the power of 2 means 3 times 3, which is 9 to the power of 2. We've got a little more simplifying to do in the first one, in the first fraction. So we've got the 8 on top, and 8 plus 1 is 9 to the power of 2, divided by 10 over 9 to the power of 2. And now I'm actually going to apply these exponents. Remember, when you're applying exponents to fractions, you apply it to the numerator and the denominator. So 8 to the power of 2 is 8 times 8, which is 64. 9 to the power of 2 is 9 times 9, which is 81, divided by, and then once again, we're applying that power to the numerator and denominator. 10 to the power of 2 is 100. 9 to the power of 2 is 81. So now we've just got a division of fractions problem. And remember, when you're dividing fractions, you keep it, change it, flip it. So we're going to keep the first fraction the way it is. We're going to change division to multiplication. And we are going to flip the second fraction upside down, or take its inverse, okay, or reciprocal. So what we're going to do now is keep the 64 over 81. We're going to change the division to multiplication, and then flip that second fraction, 81 over 100. Now remember, you can cross reduce. So we've got 81 on one diagonal. So 81 goes into 81 one time. 81 goes into 81 one time. 64 and 100, it's all really going to depend on your multiplication skills. But I know that 64 and 100 have a common factor of 4, which means that I can divide both of these by 4. So 64 divided by 4 is going to give me 16. And 100 divided by 4 is going to give me 25. And now I can multiply straight across. So 16 times 1 is 16. 1 times 25 is 25. And you always want to make sure that you don't have any other common factors, that you can't reduce any further. But I know that 16 is 4 times 4. 25 is 5 times 5. So there's no more common factors in the numerator or denominator. So that's my answer.